to make sure that you are comfortable with all three of these, because these are important. F of n says which is the best node overall cumulatively, g of n says which is the closer node from the start to right, and h of n says how far is the goal from me. Okay. And now, if you were using or if you were devising an algorithm, a search algorithm which somehow used the h function, what was my intuition? I want to go to a goal, go to a node which appears closer to the goal. So, if you wanted to change your best first search algorithm to formulate this insight, you will say f n is equal to h of n. Everybody with me? I want to make sure everybody is with me. So, let us stop at this point. This algorithm is called the greedy best first search. It says evaluation function f of n is equal to h of n. The node I am going to expand next is the node which gives me the hope that it is going to reach to a goal with the lowest cost. Its h function is the lowest. And for example, we just did one kind of h function, it is the straight line distance from n to the goal, Bucharest. Everybody with me? Any questions? So, now comes the important question, is it a good algorithm? Okay. And to understand this, let us go back to our map of Romania, and I am going to give you a slightly specific example, different example from Arad to Bucharest, but one that makes the point. So, suppose my goal is to go from this city called Iași to this city called Oradea. Okay. This is my goal. I want to go from Iași to Oradea, and let us say that I use the greedy best first search algorithm. So, let us run it. So, from Iași, what are the cities I can go to? How many cities can I go to? 2. One of them is Vaslui and one of them is Neamt. Okay. Now, which of these has a better heuristic function with respect to Oradea? Neamt. So, what is Iași going to say? Let me go to Neamt. So far so good. Now, from Neamt, how many cities can I go to? 1, Iași. Which of these cities look closer? Iași. So, I will go to Iași. And from Iași again I can go to which cities? Neamt and Vaslui. Which one is closer? Neamt. And so, basically I will keep shuttling between Iași and Neamt and Iași and Neamt and Iași and Neamt, and I will never explore anything else in the fringe.
Are we not doing duplicate?
This is on the tree search version. The question is, are we not doing duplicate detection on the tree search version? So, this tells me that at least for tree search, greedy best first search is not complete. Now, you can ask what about the graph search version, obviously, and there greedy best first search is actually complete. Okay. So, they are differing properties. And finally, in the exam I might ask you a question about some algorithm in the setting where it is graph search or tree search or with duplicate or partial duplicate detection and so on and so forth. So, I can ask you all kinds of questions. So, you have to think about properties of the algorithms along various dimensions. Now, time. Let us think about time. Do you have any guess what is the time going to be? Notice that the time will be heavily dependent on the heuristic function, because this is the additional information I have given you. I have given you additional heuristic function. I can give you a terrible heuristic function, or I can give you a really, really good heuristic function. In fact, I can give you the optimal heuristic function. What is the optimal heuristic function? The actual optimal cost from that node to the goal. I can give you the optimal, we can call it H star, right. The optimal is H star, or I can give you a heuristic function which completely confuses you. In fact, it throws you off, it takes you in the wrong direction, right. Like somebody defined an H so that I get confused, my intuitions get completely confused. That will be a Hollywood story kind of a thing, right. Somebody confuses somebody and makes them do something exactly opposite of what was optimal. So, in the worst case, if my heuristic function is really crappy, in the worst case what is going to happen? I will end up exploring all the nodes exactly, and in that setting my time would end up being order b to the power m, big O of b to the power m. So, therefore, now from now on we will not worry that much about time complexity per se, because when I give you a bad heuristic function, all bets are off. And of course, theoreticians then study that what is the error bound in the heuristic function, and based on that can I do better bounds than b to the m. But for our practical purposes, we are just going to say that look, a good heuristic can give a dramatic improvement, but in the worst case it will be terrible, both in time and space actually, believe it or not, because my fringe can become too large. And so, I may end up keeping all the nodes or most of the nodes in memory. So, my space and time bets are off, and of course, if it is not complete, then likely it is also not optimum, right. So, therefore, greedy best first search does not have great properties. Not only does it have time and space, which is going to be hard because we are dependent on the heuristic function, but it is not even complete. It gets stuck in loops, and that is not very good. We do not want an algorithm that gets stuck in loops. So, we need to do something about this. So, intuitively what is going wrong? Yes, we are repeatedly visiting some states and that is going wrong, I do agree with that. But in terms of costs, what is going wrong? So, if you think about it, initially when you expanded Nyamt, what was its g function? G function is the cost to itself. G function was 87, right, and then you had some straight line distance to the goal, and Vasloy had a g function of 92, right. But we did not even take care of g function at all, we just said, oh, Nyamt looks good because it is closer to the goal, okay, so far so good, right. But then when I came back from Nyamt to Yash, for this Yash, the g function has become 174, 87 and 87. This g function has become 174. However, the g function to Vasloy is still 92, because it is from the first Yash, not the second Yash that got encountered. And as we keep going from Yash to Nyamt to Yash to Nyamt to Yash, we are increasing the cost of the current path, but we are ignoring the cost to the current path and only looking at myopically to the extra cost that we have to give to the goal, which is what we are somehow taking the minimum over, and that is not ideal. See, what is fundamentally our objective? Our objective is to go from the start state to the goal, not from this state to the goal. This state is somewhere in the middle, but our objective is to go from the start state to the goal. And as we are taking the minimum, we should not myopically only take the minimum with respect to how much cost we are going to pay in the future, but also take minimum over the cost that we have paid so far, and somehow take the minimum over this cumulative cost, not just the future cost. Does that make sense? So, what would be a suggestion for the change in the f function that operationalizes this intuition? Somebody says alpha Gn plus beta Hn, and I am going to simplify this for now and we will come back to your suggestion later. So, I am going to simplify it to simply Gn plus Hn, and this algorithm that comes out is called the A star algorithm. Okay. So, the idea is avoid expanding paths that are already too expensive, even though they look closer to the goal, and that we achieve by saying not only look for the future cost, but add the cost, the past cost. So, right. So, Gn is the cost so far, Hn is the estimated cost to the goal, and so therefore, Fn, which is equal to Gn plus Hn in A star, should be thought of. What is the intuition? It is the estimated cost of the path from start state to the goal through n. See if you can get that intuition. It is not only looking at H, which is greedy best first search. It is not only looking at G, which is uniform cost search. It is saying, let us find that node whose estimated cost from start to the goal through it is the best. Everybody with me? Any confusions? This is an important point in the algorithm. We can stop here. Thank you.